Okay, in our last bit of notes, sorry I couldn't fit this on the other video, so it's just two videos today. What makes an atom happy or stable? So we know that group 18, our noble gases, are considered stable, but let's talk about why. So if you were to actually look at the number of electrons on each of our noble gases, you would find that their outer shell is completely full, meaning that they don't have any valence electrons. If we said our number of valence electrons determines how reactive something is, if I don't have any valence electrons, I'm not going to be reactive at all, which means that I am not going to form any bonds. We know that each atom is trying to be, or each other element that's not a noble gas, is trying to be happy or to have 8. It's usually 8, sometimes it's 2 if it's hydrogen or helium, 8 valence electrons in their outer shell. All of them want 8. So for example, 8 or 2. Lithium has 3 electrons. It has 2 in one inner shell and then 1 valence electron. Lithium is so reactive because all it has to do is ditch that electron or share it with somebody for it to, usually they ditch it, it happens in an ionic bond. So they'll give it to another element so that they're quote unquote happy with just their 2 elements, or 2 electrons left over because they're getting rid of one, they're loaning it to another element. These atoms, so group 18 atoms, are happy atoms. Don't bond with anything. I just said that. We call them inert. They're stable. Helium is the exception because it's happy or stable with only 2 valence electrons. The higher up you get in chemistry, the more you'll learn about these valence electrons. But for the purposes of today in this class, I just want you to know that an atom's goal is to either have 2 if it's hydrogen, helium, beryllium, or lithium in its outer shell, or 3 valence electrons. Or 6. I don't know why my numbers all mixed up. So they either want 2 or 6. 8. I don't know why my numbers are messed up. Probably because it's late. But 8. 8, 8, 8 is my number. 8 or 2. Very good. We'll go through that a little bit more later. So for example, here's my hydrogen atom. You can see it has its neutrons and protons, which this isn't very accurate because it would have 1 neutron and 1 proton in the middle here and 1 electron. My hydrogen atom is happy with 2 electrons in its shell, so it's going to look for a way to gain another electron. It could do this by bonding with another element, like our halogen, like chlorine, because chlorine has 7 electrons in its valence shell. So chlorine could take this electron and then hydrogen wouldn't have any, or they would bond together. So hydrogen wouldn't have any, or it would have 2. It would be happy. Again, hydrogen only has 1 valence electron, group 1A, and it doesn't follow the rule of 8, but it is happy if its number is 2. Who might hydrogen bond with to make itself happy or stable? We talked about chlorine being one possible option. When chlorine and hydrogen bond together, we get what we call hydrochloric acid, which is one of our really, really dangerous acids. It actually dissolves everything but plastic. Hydrogen could also bond with itself. So if I had 2 hydrogen atoms, you can see here they're now sharing those 2 electrons, and they're happy because they both technically have 2. Hydrogen easily bonds with itself. This way, both hydrogen atoms can share the electron and be happy or stable. Here's oxygen, for example. Oxygen has 6 valence electrons because it's found in group 6A. It needs to bond with one atom that either has 2 valence electrons or 2 atoms that have 1 valence electron. So you can see you've got the inner shell of oxygen, which only has 2, 1, 2, and then you've got the outer shell, and it has 1, 2, 3, 4, 5, 6. An atom is happy if it has 8 electrons. So how far away is oxygen from being happy? Oxygen needs 2 more electrons to be happy. We know our chemical formula for water is H2O, So in this case, my oxygen is happy because it's bonded with these two hydrogen molecules. It's stable. It makes a water molecule, H2O. Sometimes it's called the Mickey Mouse molecule because of the molecular structure and how it bonds, but that's a topic for a higher level chemistry class. But you can see now if we count, because hydrogen has donated its one, they're sharing it, and oxygen is sharing one of its electrons with hydrogen. So if you count the red dots now, it has 1, 2, 3, 4, 5, 6, 7, 8 electrons. If you count hydrogens, because remember hydrogen is happy with 2 electrons, we get 1, 2. If we count the other hydrogen, we get 1, 2. So this is a stable molecule because all of the shells on each of the atoms are happy. And this is our last slide. Again, I told you there wasn't much left to this. We'll go over valence electrons and bonding another time, as well as a little bit of how the periods work and the different groups in our periodic table. Turn your notes in. I hope you guys had a very good day. I will see you tomorrow.